In episode 54, titled CDN Decisions, Performance, Resilience, and Correct Placement, the goal is to treat a content delivery network as an architectural lever that changes user experience, origin load, and even security posture when placed correctly. A content delivery network is often introduced as a speed feature, but the exam tends to test its role in resilience and control as well. When you distribute content closer to users, you are not only shortening the distance requests travel, you are also changing how traffic reaches the origin and how much of that traffic the origin must handle. That shift can be the difference between an origin that falls over under global demand and an origin that stays stable because the edge absorbs most requests. Correct placement is therefore not just about turning on a service, but about choosing which content benefits from caching and how the edge should behave during stress. If you can explain what the edge is doing and why, you can answer CDN questions without relying on vendor details. Before we continue, a quick note: this audio course is a companion to the CloudNetX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Caching static assets is the most common value proposition because it reduces origin load and latency in a way that is both measurable and predictable. Static assets are things like images, style sheets, scripts, and downloadable files that do not change for each user on every request. When these assets are cached at the edge, users fetch them from a nearby location instead of pulling them repeatedly from the origin, which reduces round-trip time and improves page load performance. Origin load drops because the origin no longer has to serve the same asset over and over, freeing capacity for dynamic requests and reducing the chance of saturation. This is also a reliability improvement because fewer origin requests means fewer opportunities for origin timeouts and fewer cascades when origin resources are strained. The exam often frames this as reduce latency and origin load, and caching static assets is the expected mechanism. The key is that caching is not a vague concept. It is a deliberate decision to store reusable content at the edge so the origin does less work. Edge locations conserve content even during origin stress, and this is where performance decisions become resilience decisions. If the origin is slow or temporarily degraded, cached assets can still be delivered from the edge, allowing users to receive at least part of the site quickly. This can maintain a usable experience when the dynamic portion is struggling, especially for applications where static resources make up a large portion of the page weight. Edge behavior can also reduce spikes against the origin because once an asset is cached, repeated global demand no longer turns into repeated origin fetches. During flash crowds or marketing events, this can prevent the origin from being overwhelmed by repeated requests for the same heavy assets. The exam may describe an origin under stress and ask what keeps the site responsive, and a content delivery network's edge caching is often central to the answer. This is not the same as high availability for the origin, but it is an availability improvement for user-facing content delivery. The core idea is that the edge becomes a buffer between the internet and the origin, absorbing demand and smoothing spikes. A content delivery network is especially appropriate for public web applications and large media delivery because these workloads naturally benefit from distributed caching and proximity. Public web applications typically serve users in many locations, and they often include static resources that can be cached safely and served repeatedly. Large media delivery, such as video and large downloads, benefits even more because bandwidth and latency become dominant factors in user experience and cost. Delivering large media from a centralized origin can saturate links and raise transit costs, while edge delivery distributes the bandwidth burden across the network's footprint. The exam often signals this with phrases like global users or large files, and a content delivery network is the expected architecture choice. The important nuance is that not every application benefits equally, because caching requires content that is reusable and safe to store at the edge. When the workload is public and content-heavy, content delivery networks are often a strong fit because they align with both performance and scalability needs. Cache invalidation and time to live are the controls that determine freshness, and the exam often tests whether you understand that caching introduces staleness risk by default. Time to live is the duration cached content is considered valid before it must be refreshed from the origin, and it is a primary lever for balancing performance against freshness. Short time to live values increase freshness but reduce cache hit rate, while long time to live values increase cache efficiency but raise the chance users see outdated content. Cache invalidation, sometimes called purging, is the mechanism to remove or refresh cached content before time to live expires when content changes must propagate quickly. The exam expects you to recognize that caching is not fire and forget, because content changes require a strategy to ensure the right users see the right version at the right time. A good design combines sensible time-to-live defaults with a clear invalidation process for urgent updates. When you can explain how freshness is controlled, you show that you understand the operational reality of edge caching. Security benefits are often overlooked, but they matter when the content delivery network provides distributed denial of service absorption and transport layer security termination at the edge. Distributed denial of service absorption refers to the network's ability to absorb and filter large volumes of malicious traffic across a distributed edge footprint rather than forcing the origin to handle it. This can protect origin infrastructure by preventing traffic floods from reaching it in the first place, or by reducing the load that does reach it. Transport layer security termination at the edge can centralize certificate handling and ensure secure connections are established close to users, improving performance and reducing complexity at the origin. A content delivery network can also provide basic request filtering and rate-limiting capabilities that add another layer of protection for public-facing applications. The exam often frames these as security side benefits of edge placement, and they can be relevant when a scenario includes exposure to the open internet and risk of volumetric attacks. The key is that a content delivery network is not only a cache, but also a front door for public traffic that can enforce security controls. When you can describe both performance and security benefits, your understanding is aligned with the broader tested view. A scenario improving global user experience for a static-heavy site is a classic content delivery network use case because the edge can deliver most of the site quickly regardless of user location. In this scenario, the page is composed of large images, scripts, and style sheets that are identical for all users, and the origin primarily serves the initial dynamic markup or application responses. With a content delivery network, the static assets are cached at edge locations near users, so page load time improves because these large resources are fetched locally rather than across long-distance links. The origin receives fewer requests for those assets, reducing load and allowing it to respond to dynamic requests more consistently. If the origin experiences intermittent stress, users may still see fast delivery of cached resources, improving perceived reliability. The exam often describes symptoms like slow global performance and high origin load from static files, and edge caching is the correct remedy. The important point is that the content is cacheable and shared across users, which is what makes the content delivery network effective. A scenario using a content delivery network to reduce origin bandwidth costs focuses on the economics of repeated delivery rather than on latency alone. When an origin serves large, static resources to a global user base, bandwidth consumption can become expensive and can require provisioning network capacity that sits idle outside peak times. By caching those resources at the edge, repeated requests are served from the content delivery network rather than from the origin, reducing the origin's outbound bandwidth and associated costs. This can also reduce the need for scaling origin infrastructure purely to handle bandwidth, allowing resources to be sized around dynamic processing needs instead. The cost benefit is strongest when cache hit rates are high, meaning the same content is requested frequently and remains valid for reasonable time-to-live windows. The exam may present a scenario where bandwidth costs are unexpectedly high and where most traffic is for static content, and the content delivery network becomes a cost control tool. The key is that caching changes where the bytes come from, shifting delivery burden away from the origin. When you think of it as shifting bytes and load, the cost implications become intuitive. A major pitfall is caching dynamic, personalized data unintentionally, which can create both security issues and user experience problems. Dynamic, personalized data includes user-specific pages, account information, or responses that depend on authentication context, and caching it can cause one user to receive another user's content if cache keys and headers are mismanaged. This is not only a privacy breach, but also a trust-destroying event, and the exam treats it as a serious design failure. The risk often comes from overly broad caching rules or from ignoring cache control headers that are intended to prevent caching of sensitive responses. Proper cache key configuration and respect for headers like those that indicate private or no store behavior are critical. The exam may describe users seeing incorrect content or sensitive data exposure after enabling a content delivery network, and the correct diagnosis is improper caching of personalized responses. The lesson is that caching must be selective, and dynamic content must be protected from edge storage unless it is explicitly designed to be cached safely. Another pitfall is misconfigured origin rules that expose sensitive paths, because a content delivery network can unintentionally become a public conduit to origin endpoints that were not meant to be internet reachable. If the origin has administrative interfaces, internal application programming interfaces, or non-public paths, and the content delivery network forwards requests to them without restrictions, you may expose sensitive functionality to the open internet. This risk is amplified when origin access controls assume requests come only from trusted networks, because the content delivery network changes the traffic path and may bypass expected boundaries if rules are loose. Correct origin rules should restrict what paths are reachable, what methods are allowed, and what headers must be present, ensuring the edge forwards only intended public traffic. The exam often tests this by describing sensitive endpoints being accessible after adding a content delivery network, and the underlying issue is overly permissive forwarding and lack of path restrictions. The key is that content delivery networks are not just caches, they are request routers, and routing must be secured. When you treat edge forwarding rules as security policy, you avoid this pitfall. Quick wins for safe and effective content delivery network use start with defining cache rules, building a purge process, and monitoring edge and origin behavior. Cache rules should clearly specify which paths and content types are cacheable, which are never cacheable, and what time-to-live values apply to different asset classes. A purge process should exist so teams can invalidate content quickly when updates occur, especially for urgent fixes or content corrections. Monitoring should track cache hit rates, origin offload, response times, and error rates, because these metrics show whether caching is working and whether edge behavior is causing unexpected issues. Monitoring should also include visibility into what requests are reaching the origin through the edge, which helps detect misconfigured forwarding that exposes unintended paths. These quick wins reduce operational risk and make performance improvements sustainable rather than fragile. The exam often rewards answers that include monitoring and controlled invalidation because they reflect real operational maturity. When you can describe these controls, you show that you understand both the benefits and the responsibilities of edge caching. A useful memory anchor is cache, edge, protect, control freshness, because it captures the core reasons content delivery networks exist and the main operational control you must manage. Cache reminds you that the primary mechanism is storing reusable content so the origin does less work. Edge reminds you that delivery happens close to users, improving latency and smoothing demand spikes. Protect reminds you that the content delivery network can absorb attack traffic and provide secure connection handling, reducing origin exposure. Control freshness reminds you that caching introduces staleness risk that must be managed through time to live and invalidation. This anchor also helps you answer placement questions because you can ask whether the workload has cacheable content, whether users are geographically distributed, whether the origin needs protection from load or attack, and how freshness must be controlled. When you apply this anchor, content delivery network questions become structured rather than vague. It keeps performance and security in the same mental frame.
To apply these decisions, imagine being asked to decide what to cache and what not to cache for a given application, and the correct answer depends on reuse, sensitivity, and update frequency. Cache static assets that are identical for many users and that do not contain user-specific data, such as images, scripts, and style sheets, because they provide high cache hit rates and strong performance benefit. Do not cache personalized pages or responses that include authentication context unless the application is explicitly designed with safe caching semantics and correct cache keys that prevent cross-user leakage. For content that changes frequently, choose time-to-live values that balance freshness with cache efficiency and ensure a purge process exists for urgent changes. Also decide which origin paths should never be exposed through the edge and restrict forwarding rules to protect sensitive endpoints. The exam expects you to demonstrate selectivity rather than blanket caching, because blanket caching is where the major risks appear. When you can justify why something is cacheable or not, you demonstrate mature reasoning about edge placement.
To close episode 54, titled CDN Decisions, Performance, Resilience, and Correct Placement, the key idea is that a content delivery network improves performance and resilience by caching reusable content at edge locations close to users while reducing origin load. Static asset caching reduces latency and origin bandwidth, and the edge can keep serving cached content even when the origin is under stress, improving perceived availability. Control of freshness through time to live and invalidation is essential because caching introduces staleness by default, and operational processes must exist to manage updates. Security benefits, such as distributed denial of service absorption and edge transport layer security handling, can further protect public web applications, but they require correct origin rules to avoid exposing sensitive paths. The biggest pitfalls are unintentionally caching dynamic personalized data and misconfiguring forwarding in ways that broaden public exposure. Quick wins come from clear cache rules, a purge process, and monitoring that validates cache behavior and origin offload. Your rehearsal assignment is a caching rule rehearsal where you state one cacheable path, one non-cacheable path, and the time to live logic for each, because that simple exercise mirrors how the exam expects you to think about correct content delivery network placement. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.